Number 1. A curve has equation y equals to 2x half minus 1. Find the equation of the normal to the curve at the point A, 4, 3, give you answer in the form of y equals to mx plus c. So to find the equation of the normal, first we have to find the gradient of the tangent. The gradient of the tangent is the first derivative. So dy dx, we derive. So half times 2 x to the power of half minus 1. And then 1 derived is 0. So equals to x to the power of negative half. At x equals to 4, the gradient of the tangent is equals to 4 to the power of negative half. So equals to 1 over 2. So this is the gradient of the tangent. Now the gradient of the normal is the perpendicular to the tangent. So this is the tangent and this is the normal. So the gradient of the perpendicular lines is equals to negative 1 over m, equals to negative 1 over 1 over 2. So equals to negative 2. So the equation of the normal is equals to y equals to mx plus c. We put the gradient normal is negative 2, x is 4, and y is 3. To find the c, so we can have c equals to 11. So the equation of the normal is y equals to minus 2x plus 11. A point is moving along a curve in such a way that at A, the rate of increase of the x-coordinate is 3. This one, rate of increase, this is the rate of change. So we can rewrite the rate of increase of x-coordinate as the dx over dt. Yeah, since the rate means the speed or the change according to the time, so it's dx over dt equals to 0 equals to 3. Find the rate of increase of the y coordinates of A. So we are looking for dy dt. Now using the chain rule, you can find dy dt from dy dx times dx dt. So the dy dx is, at point A, we have the dy dx. This is point A. So the dy dx is equals to half. So we put the dy dx formula, x minus half times dx dt is 3. So it's 4 minus half times 3 equals to, it's 3 over 2. That's the dy dx times dx dt. So this is the dy dt, centimeter per second. At A, the moving point suddenly changed direction, the speed, and moved down the normal in such a way that the rate of decrease of the y coordinate. So now rate of decrease of y coordinate. So dy dt is equal to negative 5. This is negative because it is a decrease. So it's negative. As the point moved down the normal, find the rate of change of its x-coordinate. So we find the dx dt. So again, we can find the dx dt using the chain rule. So we can use this formula. The dy dt equals to dy dx times dx dt. The dy dt is equals to -5. dy dx is the dy dx of the normal now, because the point moved down the normal. So at point A, the dx dt, the dy dx, is half, and the normal gradient of the normal is -2 at A. So in here, since this is a normal, so we use the -2 instead of using the half, because half is the dy dx at A for the tangent, for the curve. But for the normal at A, the dy dx is equals to -2. So -2 times the dx dt. So we get the dx dt equals to 5/2 centimeter per second. So we can see that we know that on the curve, so we can see that this is a curve, this is the tangent, and this is the normal at A. So when the points move along the normal, the y is decreasing, the x is increasing, y is decreasing, x is increasing. You can see that the y is negative, the rate of change of y, but the rate of change of x is positive. Number 2. The equation of the curve y at x is this. Find the x coordinate of the stationary point and curve and determine their nature. So to find the stationary point, first we have to find the derivative dy dx equals to 0 for the stationary point. So we derive this for x minus 3 to the power of 5/3. So 5/3 times for x minus 3 to the power of, we minus the power by 1, it's 2/3. Then times with the derivative of 4x minus 3, which is 4. Minus 20/3x, it's become 20/3 equals to 0. So 20/3 for x minus 3 to the power of 2/3 equals to 20/3. I can cancel. So for x minus 3, 2/3 equals to 1. That means for x minus 3 equals 2. So we cube and then we square root on both sides. So we to the power of 3/2 to the power of 3/2 on both sides. So we have, it is 1, or for x minus 3 is equals to -1, because it contains the square root, so the result should be plus and minus. So for x equals to 4, x equals to 1, or for x equals to 2, x equals to half. So we have the x coordinates of the stationary point, and now we have to determine the nature. So we need to find the second derivative. The second derivative is from the derivative of the first derivative. So we simplify the first derivative first. The first derivative is 20/3 for x minus 3, 2/3 minus 20/3. So the second derivative will be equals to the power multiplied, so 2/3 times 20/3 for x minus 3 to the power of -1/3. Yeah, we minus by 1 times the derivative of 4x minus 3 times 4. And that's it, because the -20/3 will be derived into 0. So we simplify. It is for t 160 over 9, for x minus 3, negative 1/3. Okay, now we check the stationary points. When x equals to half, we have the second derivative as 160 over 9 times 4x minus 3 to the power 1/3. So the 4x minus 3, I can put it as negative 1. So it's negative 1, negative 1/3. So this is negative 1. So negative 160 over 9. So this is smaller than 0. That means it is a maximum point. When x equals to 1, the second derivative will be equals to 160 over 9 times the 4x minus 3 is equals to 1. So it's positive. So this is a minimum point. So this one will be the maximum, and this will be the minimum. B, state the set of values for which the function is increasing. So from the previous question, we have the two stationary points. We have half and 1. And we know that, so this is a minimum point, and this is a maximum. So the maximum point means the gradient before the stationary point. Half is the stationary point, yeah? So this is the number line of the gradient. The gradient before the maximum point, the stationary point, is positive because it's increasing function. And then after the stationary point, it will be minimum or decreasing function. And for the stationary point, the second one, when x equals to 1, it is a minimum. So before the minimum point, it is a decreasing function. The gradient is negative. This is the gradient positive. After the minimum point, the stationary point, the gradient will be positive increase. So the function will be increasing at these regions. So when x is smaller than half or x greater than 1. So we can determine the increasing and decreasing region using the number line of the first derivative. So we do the gradient check, yeah, around the stationary points. Number 3, the points P lies on the line with equation y equals to mx plus c, where m and c are positive constants. A curve has equation c positive constant, yeah. There is a single point P on the curve that's the straight line is a tangent. So this line is a tangent to this curve. So that means we can equalize these two equations. So minus f over x equals to mx plus c. And I can multiply by x, it's negative m equals to mx squared plus cx. So mx squared plus cx plus m equals to 0. Since they are a tangent and the curve, so we can see the relationship from the discriminant. The discriminant should be equals to 0 for the quadratic equation to have the tangent, the line as the tangent. So the discriminant is b squared. So this will be a, this will be b, and this will be c. So b squared minus 4ac equals to 0. So the b is c squared, minus 4a is m, and c is m, equals to 0. So c squared equals to minus 4m squared equals to 0. So c squared equals to 4m squared. So c equals to plus minus 2m. But since c are the positive constant, so c equals to 2m. Now to find the coordinates, that means we have to solve this quadratic equation. So we solve it. We replace the value of c. So mx squared plus c is 2mx plus m equals to 0. Now we solve this. I factorize m, x squared plus 2x plus 1 equals to 0. And this can be simplified using the completing the square as x plus 1 squared. Since m cannot be 0, so x plus 1 squared should be equals to 0, and x equals to negative 1. So x equals to negative 1 and y will be equals to, I put it into the curve. It's negative m over negative 1 equals to m. So the coordinate of p will be negative 1, comma m. The normal to the curve at p intersect the curve again at point q. Find the coordinate of q in terms of m. So we have to find the equation of the normal at point p. So we know that the tangent is y equals to mx plus c. The tangent is y equals to mx plus c. Y equals to mx plus the c is to m. Now the normal now will have the gradient of negative 1 over m tangent, which is negative 1 over m, because the gradient of the tangent is m here. So the equation of the normal will be negative 1 over mx plus c, 1. So this is another c that different from the tangent. So we need to find the c1. So the normal passes through the p. So it passes through the coordinates of p. So we put at p, y is m minus 1 over m, x is negative 1 plus c1. So I can have c1 as m minus 1 over m. So the equation of the tangent will be y equals to negative 1 over mx plus m minus 1 over m. Or I can rewrite as 1 plus m squared minus 1 over m. This is the equation of the normal. Now, the normal cuts the p again at point q. So we equalize the function. So it's negative m over x, yeah, the equation of the curve again, negative m over x, equation of the curve equals to equation of the normal, minus 1 over mx plus m squared minus m minus 1 over m. So I can multiply by x, so it's negative m equals to minus 1 over m x squared plus m squared minus 1 over m x. So again, we have quadratic equation 1 over m x squared minus m squared minus 1 over mx minus m equals to 0. So I better to multiply by m here. So I have x squared minus m squared minus 1x minus m squared equals to 0. Now that means we have to solve to find the coordinates of q. So we solve this equations. So this will be a, this one, this will be b, and this will be c. So the x is minus b plus minus root of b square minus 4ac over 2a. So negative b is negative m square minus 1. So it's m square minus 1 plus minus square root of b square. So it's m square minus 1 squared. I ignore the negative in b because it's being squared. It's also positive, yeah? It's supposed to be negative, but it's being squared. So it will be a positive. Minus 4, a will be 1, and c will be negative m squared over 2a, 2 times 1. So m squared minus 1 plus minus the root of, okay, I rewrite as m squared minus 1 squared plus 4m squared, 2. So m squared minus 1 plus minus the root of, I expand, m4 minus 2m squared plus 1 plus 4m squared over 2. So I have m squared minus 1 plus minus root of m4 plus 2m squared plus 1 over 2. So I can factorize this or rewrite this as m squared plus 1 squared. So that means we can cancel the square root. So the x will be m squared minus 1 plus, yeah, we cancel the square root here, m squared plus 1 over 2, which is equals to m squared. And the other x will be, let's put it here, it's m squared minus 1 minus m squared plus 1 over 2. So equals to minus 1. Find the coordinates of Q. So if we see here, we can find the y. So the y, if x equals to m squared, I use again the equation of the curve. So it is negative m over m squared equals to negative 1 over m. So the coordinates are m squared negative 1 over m. This one I put again negative m over negative 1, so it is m. So the coordinates are negative 1, comma m. Now negative 1, comma m is p. Yeah. So that means this will be the q, the coordinate of q. Number 4. The volume V of the large circular mound of iron ore of radius r is modeled by a equation. Iron ore is added to the mound at a constant rate of 1.5 meter cube per second. You see that this is a meter cube, so the unit of volume. So that means constant rate of this is the rate of change of the volume. It's 1.5. Find the rate at which the radius. So we find the dr dt when the radius is 5.5. So to find the dr dt, we can use the chain rule dv dt equals to dv dr times dr dt. So first we need to find the dv dr. Okay, so phi, we know that phi is 3 over 2 r minus half cube minus 1. So we can find dv dr. So we use the chain rule here, the 3 times 3 over 2 r minus half square times 1, yeah, the derivative of the inner function, minus 1. minus 1 derived is equals to 0. So this is 0, yeah? Equals to negative 9 over 2 r minus half squared. So we can find when the radius is 5.5. So when r equals to 5.5, the dV/dr will be equals to 9 over 2 times 5.5 minus half is 5 squared. So 9 over 2 times 25 equals to 225 over 2. So now we can put it in here. So dV dt is 1.5 equals to 225 over 2 times dr dt. So dr dt will be equals to 1.5 divided by 225 over 2. So 1 over 75 centimeter per second. Find the volume of the mound at the instant when the radius is increasing. Okay, now we are having the dr dt is equals to 0.1. So we need to find the volume. So we have to find the dV. How do you find that? Dr dt is 0.1. So we have the dV dt equals to dV dr times dr dt. Now the dV dt will be constant, right? So I can put 1.5, the dV dr. Now the dV dr will be changed times dr dt is 0.1. So dV dr will be equals to 15 centimeter cube per second, per centimeter. Now we know the dV dr. So we can use the first derivative here. dV dr is, so 15 equals to, dV dr is 9 over 2 r minus half squared. So 15 divided by 9 over 2 equals to 10 over 3. 10 over 3 equals to r minus half squared. So r minus half equals to root of 10 over 3. It is 1.83. So r will be equals to 2.33 centimeters. The other one, r minus half, will be negative 1.83. But since r cannot be negative, so we reject this. Okay, now we have the r. So we can find the volume. The volume is 3 over 2 r minus half cube minus 1. So that means I can just put the value of r minus half. So 3 over 2 r minus half is 1.83 cube minus 1. So it's 10 over 3. And then you square it. And then you cube it. You cube times 3 over 2 minus 1. So the volume is 8.13 centimeter cube. We continue to the next part.